Now we discuss the first shifting property. First shifting property, also known as a first shifting theorem and also known as a first translation theorem. So we may also write this one as a first translation theorem. This one is also known as a first translation theorem. First translation theorem. Translation. First translation theorem. First translation theorem. So now, what is the statement of a first shifting property or first shifting theorem? What is the statement? So here we write a theorem. If Laplace transform of a ft equal fs, then Laplace transform of a e to power at ft equal f of s minus a. Means if we have a Laplace transform of a ft and if we try to find out the Laplace transform of a e to power at into ft, then in place of a s, what we write? In place of a s, we write s minus a in order to find out the Laplace transform of a e to power at into ft. This one is a what? This one is application of a first shifting theorem. So before solving a numerical example, now we try to prove this theorem. So what is the proof of this theorem? How we prove this one? By the definition of a Laplace transform, how we write means we try to find out a Laplace transform of a e to power at ft. So here we write what? By definition of Laplace transform of a e to power at ft equal 0 to infinite e to power minus st. In place of ft, what we write? In place of ft, we write e to power at into ft. So e to power minus st into e to power at ft dt. Now this become what? After simplification, here e minus st e to power at. So we may write this one 0 to infinite e to power minus what? S minus a t ft dt. Now we transform this s minus a into another, means another variable. Here we write what? What we write here, you may directly write here e to power minus s minus a t ft dt. There is no need to transform in means a change in other variables. Now what is the given? Given is a what? Laplace transform of a ft is a fs. Laplace transform of a ft is a what? Laplace transform of a ft is a fs. Laplace transform for. So if we write in a second phase, what will happen here? So in a next phase, Laplace transform of a, once we write the expression of a previous phase, Laplace transform of a e to power at ft equal 0 to infinite e to power minus s minus a t ft dt. Now what is given? Given is a Laplace transform of ft is a capital Fs. So, here given Laplace transform of ft equal fs equal, by the definition of a Laplace transform, this one equal what? 0 to infinite e to power minus st ft dt. So, this one is a first, if we assume that this one is a first expression and this is a second expression. If we closely observe the first and second expression, fs equal e to power minus st ft dt. Then if we try to write this expression in term of a s, in variable of a s. So, what will happen? If there is a s, then this one is a function of a s. So, here in place of a s, what will happen here? Here s minus a. So, this become what? Now, equation first using equation 2 Laplace transform of e to power at ft dt ft equal 0 to infinite e to power minus s minus a t ft dt equal what? Equal, in place of a s we write what? In place of s we write s minus a. So, this become f of s minus a. So, this one is approved. This one is a what? This one is approved. So, as we say that, what is the application of this one? What is the application of a first shifting theorem or first shifting property? If we have a Laplace transform of a ft, then be able to find out the Laplace transform of a e to power at into ft by replacing or by changing s by s minus a. Now, we try to solve some numerical example based on a first shifting property. So, already here we write some numerical problem based on a first shifting property. What is the numerical problem? Numerical problem is find the Laplace transform of a following function. First function is e to power at cos bt. Second function is a t plus 3 whole square into e to power t. Third function is a e to power minus at into t to power n minus 1 upon factorial n minus 1. And fourth question is a t to power 5 into e to power 3t. Here now we are going to solve these numerical problem using the first shifting property. Now, how we solve? Solution of a first one. So, once here we write a first shifting property. First we write a first shifting property. By first shifting property, by first shifting property, Laplace transform of a e to power at ft equal f of s minus a. F of s minus a if Laplace transform of a ft equal what? Laplace transform of a ft equal fs. So, suppose this is the expression 1. Here we write a first shifting property. So, if we compare the first numerical example, comparing with first shifting property, first shifting property. Comparing with first shifting property, what is the ft? If we compare here e to power at, here e to power at. What is the ft? ft is a cos bt. So, what is the ft? ft become ft equal cos bt. Cos bt. ft equal cos bt. Now, as we know that, what is the Laplace transform of cos at? Cos at is a s upon s square plus a square. So, here once you, if you may verify this one, here we write a Laplace transform of a cos at is a s upon s square plus a square. Now, comparing with the first shifting property, ft become cos bt. So, now what is the Laplace transform of ft? Laplace transform of ft become Laplace transform of a cos bt. Cos bt, and we know that Laplace transform of a cos bt is what? S upon s square plus v square. S square plus v square. Now, using the shifting property, Laplace transform of ft, once again if we write Laplace transform of cos bt equal s upon s square plus v square. Now, by shifting property, Laplace transform of e to power at ft, ft equal what? And if we denote this Laplace transform by the capital Fs. So, by shifting property, this one equal f of s minus a. We may write here by shifting property. By shifting property. By shifting property. So, in place of a s, we write what? S minus a. Now, fs minus a become here e to power at cos bt. So, in place of s, we write s minus a. So, this become s minus a upon s minus a whole square plus v square. After simplification, this become s minus a upon s square plus a square minus 2as plus b square. This is the Laplace transform of e to power at ft, e to power at ft, or we may also write Laplace transform of e to power at cos bt, cos vt equal to this one. Similarly, we try to solve second numerical example. Second problem. What is the second numerical problem? Second numerical problem is a t plus 3 whole square into e to power t. T plus 3 whole square into e to power t. Second, find the Laplace transform of what? T plus 3 whole square into e to power t. Into e to power t. Into e to power t. So, comparing with the comparing with shifting property, with first shifting property, comparing with form of a first shifting property, form of first shifting property, what is the ft? ft become ft equal t plus 3 whole square, t plus 3 whole square, t plus 3 whole square. Now, we find the Laplace transform of ft. Laplace transform of ft equal Laplace transform for t plus 3 whole square, and this one equal Laplace transform of a t square plus 9 plus 60. Now using the property of a linearity, this one equal Laplace transform of a t square plus Laplace transform of a 9 plus 6 time of a Laplace transform of a t. So now using the standard result of a elementary function, Laplace transform for t square become what? As we know that the Laplace transform of what? Laplace transform of a t to power n equal factorial n upon s to power n plus 1. Factorial n upon s to power n plus 1. So here t square n be the 2, so factorial 2 upon s cube. Factorial 2 upon s cube plus Laplace transform of a 9 means 9 become outside, 9 into Laplace transform of a 1. Using the linearity property, this become 9 times of a Laplace transform of a 1 be the 1 upon s plus 6 time of a Laplace transform of a t be the 1 upon s square. 1 upon s square. So after simplification, this become what? This become, in a denominator this become s cube, in a numerator this become 2 plus 9s here 9s square plus 6s. So what is the final result? If we write s square first, so this become 9s square plus 6s plus 2 upon s cube. Laplace transform of a t plus 3 whole square. Laplace transform of a ft. Now using the shifting property, now Laplace transform of a e to power t ft equal what? Equal f of s minus 1, because here a is a what? A is a 1. If we compare with the standard form, what is the standard form? Standard form is a Laplace transform of e to power at ft equal e to power f of s minus a. So here a is a what? A is a 1. Here a is a 1, so this become f of s minus 1. Now since Laplace transform of a here we find the Laplace transform of a ft. Laplace transform of a ft is a what? Laplace transform of a ft equal 9s square plus 6s plus 2 plus 6s plus 2 divided by s cube. This one equal what? This one equal capital Fs. This is a capital Fs. Okay. So if this one is a capital Fs, so what is a Fs minus 1? Now Laplace transform of a e to power t ft equal, in place of a s, what we write? In place of a s we write s minus 1. So 9 time of a what? S minus 1 whole square plus 6 time of a s minus 1 plus 2 divided by what? Divided by s minus 1 whole cube. So if we simplify this expression, this become 9s square plus 9 minus 18s plus 6s minus 6 plus 2. Minus 6 plus 2, so divided by what? Divided by s minus 1 whole cube. Whole cube, if we simplify this result, what is the result? 9s square minus 18s plus 6s become 12s, and plus 9 plus 2 become 11, minus 6, 11 minus 6 become 5. So, what is the result? Result if we write in a next phase, this become what? 9s square minus 12s plus what? Plus 9 to 11 minus 6, 11 minus 6 become 5, plus 5 upon s minus 1 whole cube. This one is a what? This one is a Laplace transform of a what? Laplace transform of a e to power t ft. And what is the ft? Laplace transform of a e to power t. Ft is a t. Ft is a what? Ft is a t plus 3 whole square. T plus 3 whole square equal 9s square minus 12s plus 5 upon s minus 1 whole cube. This one is the answer. Now, once we verify the result, so this one is the answer. So, this one is the answer. First, we write ft. Ft is the coefficient of e to power something is nothing else ft. Here ft is a t plus 3 whole square. So, once we find the Laplace transform of ft, then replace s by the s minus a. Here a is a 1. In a similar manner, we also solve other problem, means we may solve the third one. So, firstly we solve this one. Third one is what? T to power minus at, t to power n minus 1 upon factorial n minus 1. So, third one, what is the third problem? Third problem is find the Laplace transform of e to power minus at, t to power n minus 1 upon factorial n minus 1. So, if we compare with the standard form of a shifting property, now what is the ft? Here not here, let ft equal t to power n minus 1 upon factorial n minus 1. Let ft equal t to power n minus 1 upon factorial n minus 1. Now, Laplace transform of a ft, Laplace transform of ft equal Laplace transform of a t to power n minus 1 upon factorial n minus 1, factorial n minus 1, using the linearity property 1 upon factorial n minus 1 become outside into Laplace transform of a t to power n minus 1, and we know that the Laplace transform of a t to power n minus 1 is a what? 1 upon factorial n minus 1 outside. Laplace transform of a t to power n minus 1 is a what? Factorial n minus 1 divided by s into n minus 1 plus 1. So, this become what? Factorial n minus 1, factorial n minus 1 cancel out. Laplace transform of a ft become what? Ft become 1 upon s to power n. 1 upon s to power n. Now, by shifting property, and we will denote this expression by the capital Fs, capital Fs. Now, by shifting property, so if we write in a next space or in this space, so if we write here, now by shifting property, now by shifting property, now by first shifting property we write here, first shifting property, first shifting property. Now, by first shifting property, what will happen? Laplace transform of e to power minus at ft equal what? F of s plus a, because in place of a, what is here? In place of a, there is a minus a. So, s in place of s minus a, we write s plus a. So, f of s is a 1 upon Sn. So, what is f of s plus a? 1 upon s plus a is s plus a is a s plus a to power n. So, this one is a what? This one is a answer. This one is a answer. This one is a Laplace transform for this expression. Laplace transform for this expression. So, similarly, we very easily solve the fourth one. Fourth one, what is the fourth one? Fourth one is a Laplace transform of t to power 5 e to power 3t. So, t to power 5, t to power 5. So, fourth question is a find the Laplace transform of t to power 5 e to power 3t. E to power 3t. So, let here what? Solution, let ft equal t to power 5. Ft equal t to power 5. So, what is the Laplace transform of ft? Laplace transform of ft is a Laplace transform for t to power 5. So, Laplace transform for t to power 5 is a what? Factorial 5 upon s to power 5 plus 1. Because we know that Laplace transform for t to power n is a what? Factorial n upon s to power n plus 1. S to power n plus 1. So, what is the factorial 5? 5 4s are 20, 120. 5 4s are 20, 360, 120 divided by what? S to power 6. S to power 6. Now, what is the Laplace transform for this one? Now, by first shifting property, we denote this one equal to what? This one equal to Fs. By first shifting property, now by first shifting property, Laplace transform of e to power 3t ft, if we compare e to power at, what is the value of a here? The value of a is a what? The value of a is a 3. So, this become what? F of s minus 3. F of s minus 3. So, f of s is a 120 upon s to power 6. So, what is the value of f of s minus 3? This become 120 divided by s minus 3 to power 6. This one is a what? This one is the answer. Once we verify this one, so this one is the answer. T cube. Okay. Obviously, this one is the answer. So, because t to power 5 is factorial 5 upon s to power 6, s minus 3 to power 6. So, it is not a very tough task. So, it is a very easy to apply the first shifting property. Let ft equal cos bt, find the Laplace transform of cos bt. Then let Laplace transform of cos bt be the fs. In fs, we write in place of s, we write s minus a. Here a is a what? A is a 1. Once we find the Laplace transform for t plus 3 whole square, then we replace s by s minus 1. Here a is a minus 1. So, here once we find the Laplace transform of remaining part of a function after multiplication of e to power minus at. So, once we find the Laplace transform for this one, then we replace s by s plus a. Here we find the Laplace transform for t to power 5, then replace s by s minus 3. So, this one is a what? This one is a This one is these are the numerical problem based on a first shifting property. Now, next one is a what? Next one is a